All right, today's lesson is on factorials and permutations. Factorials and permutations. You should be excited about this, and I guarantee you are going to be so excited about this. You are going to write so many exclamation marks today because you're so excited about this. I promise you. Every student is excited about this. I haven't seen a student who hasn't done the homework for this and not been excited. Seriously. All right. And for those sponsors who are looking for someone with great humor, look no further. I'm right here. Please contact me. Scams not allowed. Okay. Factorial notation is used to represent the multiplication of a string of consecutive numbers starting with 1. An exclamation mark is written after the number to indicate the end number of the string.
Factorials and permutations.
Who wants to volunteer and have everybody in this room think they're an amazing person? Ashley.
I mean, I hope there's something.
Hand one
Almost
of these.
everyone.
If you notice, the top of that page is this, so it's already been given to you. You don't need to copy it out. No way. I couldn't remember if I had this on the thing, otherwise I would have told you before. I forgot I had printed them off until just when I started the lesson.
So we don't have to make a note for this?
Pardon?
So we don't have to make a note for this?
Yeah, that's right. It's just a fill in the blank. Thanks to Ashley. Hey, round of applause for Ashley. There you go, round of applause. All right, so n factorial simply means n times 1 less than n, times 2 less than n, times 3 less than n, until you get down to 3, 2, 1, and you're done. So 7 factorial, what's that equal to? Go ahead, Georgia.
Is it 7 times 6 times 5 times 4 times 3 times 2 times 1?
That's it. That's 7 factorial. Okay? That's not too bad.
Are we going to talk about 52 factorial?
Why?
Because it's a popular number.
Is it?
Yeah.
Why is 52 factorial a popular number?
Really, really, really big. Factorial.
It is really big.
They think 52 is a second part.
That would be the number of ways you could deal out a deck of cards. All right. So simply, let's calculate each factorial, but I want you to do it with your calculator. Your calculator has an excited button on it. A factorial button. So mine is that. It's over the 4. Let's see where yours is. Right there. Here's how you do it. You press probability, and then you hold to that. So 5, probability, over. Yes, we will use the other ones. Okay. You need to find it on your calc? So 5 factorial. And then you press probability, and then you see factorial symbol. Anybody having problems finding your factorial button? I mean, that's the whole point for this first question. So if I want to do 5 factorial, I do 5, press the calculator button, and then shift over to the factorial symbol. So do all of these, okay? 3 factorial.
Oh, whoa. Wait, 6, yeah. 126. Why is that so long?
You need help? Hey. Who got these answers? Who's excited about that?
Yeah.
There you go. There you go. We're going to explain what it means. Right now, it's just like a new operation, like sine, cos, or tan, or multiplying, or adding, or subtracting. You now have a new operation called factorial. Okay? Guys, be with me. Now, simplify. I don't want to put 72 factorial into my computer, into my calculator, because my calculator's not going to like it. It says error. These numbers get very big, okay? So I want to see if I can simplify this. Well, let's look at 10 factorial over 7 factorial. Well, that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? So right now I can cancel all of these. And I'm just left with 10 times 9 times 8. But you can even think of 10 factorial is equal to 10 times 9 times 8 times 7 factorial all over 7 factorial, and then just cancel those. Okay? That's an easier way of writing it. So 10 times 9 times 8, 720. Try 72 factorial divided by 68 factorial. Simplify it and evaluate. What do we get? Ethan.
24,690,906.
Okay, 24 million.
690,000.
Yeah.
960.
Like this?
Yeah.
It's interesting.
How did we get that?
Can you confirm that number?
I got
Yep. There you go. Wow, that's a lot. That's a lot, and we only multiplied a couple numbers together. What is this C? Mine's not working. Yours is not working?
Well, I can't drag the C.
Yeah.
Well, there.
Well,
Oh, yeah.
just let me.
Shut up, dude.
And for the robot overlords who are definitely watching this stream, I wouldn't kick out your plug, is all I have to say. Some of us might. Yes, Sophia? I don't do 72 exclamation mark. Then that's factorial. What I do is I have to rewrite 72 factorial as 72 times 71 times 70 times 69 times 68 factorial. And then I still divide that by 68 factorial. And then these cancel out. Okay? That's right. No, I don't need to do any division by 68. I just do 72 times 71 times 70 times 69. Just those four numbers multiplied together.
But if we take out 7 and if we take out 68, why do we still have to
Okay.
add them? What?
Guys, come on. It's a lesson, and I'm trying to hear people talk. And you're talking over me. And them. Asley, sorry.
Never mind.
No, please ask. I think it was a good question.
But if you take out, I get why you take out like the 7 and the 68, but why are we still adding them when we add them? Like when I add 72, 71, 70, 69, 68, why are we adding?
I don't do 68.
You don't?
No, I just do 72 times 71 times 70 times 69. The 68 factorial has canceled out with 68 factorial. And anything divided by itself is equal to what? 1. That's right. I like everybody. All right, 7 factorial over 10 factorial. Any guesses? Thank you.
1 over 720.
Yep. For the exact same reason the other one is. It's just a reciprocal, right? So the only reason I showed this one is that the rule works both if it's in the numerator or in the denominator. All right. Let's move on. If you could write this down. Oh, all right. Well, let's read it together. Permutations of n objects taken n at a time. So what this means is, I want to take 6 things and order them. Okay? I take 6 people's calculators that are different, and I'm going to order them on a table. The question might be, how many different ways can I order them? Okay? Permutations help us solve this. So a permutation is an arrangement of objects in a certain order. The order matters. Okay? The total number of permutations is denoted by NPN. This is the notation I'll use. This P and N, I don't know if your textbook uses or not. I haven't looked yet. But the NPN is the notation that I will use. All right, so Adam Scott is learning 6 songs for the spring concert. How many ways can these songs be arranged for the concert program? Well, what you were doing is we're gonna arrange them, and the order makes a difference, right? Like, you know, with bands, they leave some of their big songs for right at the very end. Right? Because they want to finish on a high. So the order makes a difference. So let's just make a note of that. Order is important. And there's 6 of them. So we're going to do 6 permeate 6. We're going to take 6 songs and we're going to order 6 of them. I know that seems weird for now, but we're not always going to be ordering all 6. On your calculator, for those of you who needed to press the probability button for to get the factorial, you'll have to press the probability button for this as well. You will find an NPR button somewhere on your calculator. There will be an NPR button. And what you need to do is you need to type in 6 and then this NPR button, and then you're going to type in 6 equals. Oh, you have the answer? All right, Emma, what was the answer? 720. I'd like you also to try doing 6 factorial and tell me what that is. What's 6 factorial? 720. So in general, NPN is equal to n factorial. Okay, they're the same thing. Okay. Now, that's handy, right? I want to seat students in the class. Well, the order makes a difference, right? If I had Alex where Molly is sitting and Molly where Alex is sitting, that's a different classroom layout, right? Even if I just made that one change. So you can imagine for 26 students, 26 factorial ways of organizing. I have a lot of choice in how I'm going to organize my class. All right? But sometimes we don't want to always order everything. Like, for example, I want to take a subset. I want to make a classroom student council. So I'm going to take the 26 people in here and I'm going to pick 4. The first person I pick is going to be the president. The second person is going to be the vice president. The third person is going to be the treasurer. And the fourth person is going to be the secretary. So those are the 4 roles. And the order makes a difference. Because if I pick Elise first, she's going to be the president. If I pick her third, she's going to be the treasurer, I think I said. Okay? So here we have an investment club with 5 members wants to select a president and a vice president. And how many ways can this be done? So, what is our N and what is our R? N is the total number of objects. So in this case, what's the total number of objects? Georgia? 5. And I want to select a subset of that. How many people do I want to select? Jacob? 2. So I'm going to do 5 permeate 2. But I don't want to do this with my calculator in one step, okay? I want to do, this is n factorial, so 5 factorial over 5 minus 2 factorial. Is equal to 5 factorial over 3 factorial is equal to 5 times 4 is equal to 20. Travis.
So does the 2 represent the fact that you're only selecting the president and the vice president?
That's exactly what it represents.
Okay.
That's exactly what it represents. president and vice president? There you go, great question. So on your calculators, can you please do 5 permeate 2 and confirm that you get 20? I got 20. Try 2 permeate 5. Error, why? Georgia.
Because 5 is a bigger number than 2.
So what difference does that make?
Well, it means you can't pick 5 things from 2 things.
Right. I can't take 2 people and fill 5 positions with those 2 people. Exactly. All right. So how many 3-letter words can be formed using the letters in the word justice? I'd like you to work that out on your own, and we'll take it up in 2 minutes. Sophia. Remember, 5 factorial is 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. But these cancel. And so I'm just left with 5 times 4. Georgia, don't give me the answer.
I'm assuming the words don't have to make sense.
Words do not have to make sense. Juice.
Because I don't think that the amount of words you can get out of
That's not a 3-letter word.
No, G-U-S, juice.
Oh, juice.
There's no real use out of that.
I've only got 2.
Not real words.
Are we calculating this with the numbers?
We're doing it with permeation. So words in quotes is not real words.
What?
2. I'm sticking to my
No,
gun.
I'm up to 2, I'm going.
Okay.
Here you go.
I still think 2.
Ice is 2.
How about sick?
Yeah.
Yeah,
That's
sick,
4.
is, it's,
You're rolling a bit too fast.
etc.
We're rolling too fast. We need to slow it down. Here we go. I think I'm at 5.
You got touch.
5.
Tick. That's
Tick,
ice.
yeah,
Ice.
baby.
I think we're up to 7.
On a more serious note, what are we actually calculating here? What am I going to write that's like this? Hunter. Okay, try the question. Travis.
Would N be 7 and then R is 3?
Who thinks N is 7 and R is 3? I agree. 7 permeate 3, which is 7 factorial over 7 minus 3 factorial. 7 factorial over 4 factorial. 7 times 6 times 5. Abby. 210. There are 210 words. But one of the words is SJT, right? Like it's not an English word, it's just a word.
What language is it?
Math. Yes, Joey. How did I get 7? Okay, so let me throw that out to the class. How did we get 7? Hunter. Because there's 7 letters in justice. Now, I'm going to just give you a little heads up about what we're doing tomorrow. One important thing is none of the letters are the same. Because if letters are the same, we have to change it again. Okay? That's the end of the note. So now, what's that I hear? Yes, I will assign some home fun. That sounds fun for you.
Also, I have a question.
Just 1 second, please. First things first, I made a mistake yesterday, and I assigned the wrong homework. So I'm going to fix that.
Oh my gosh, I think we deserve the only one because we did the wrong one yesterday.
You did the wrong homework. I mean, you did good homework. It wasn't bad, but I had skipped that lesson. And then I assigned it to you anyway.
So now we're doing.
All right, I'll only assign just a little bit. And now for the permutations. For permutations and factorials. So today's stuff, it's on page 80. How long do we want this assignment? Super long, okay.
No, a little bit short. A lot short.
Yeah. Yeah. You double check. The rest of
One to 5. Eight to 12. 16 and 17.
62
Fine. 16 to 17 inclusive.
That's better, Cam, thank you.
All right. And that's the stream. Let me